Section 21, Fall Protection. The references for this section are EM 385, TAC 1, TAC 1, Section 21, 29 CFR 1926.500, Subpart M, 29 CFR 1910, Notices of Proposed Rulemaking, 29 CFR 1910, dated May 2010, ANSI Z 359, Fall Protection Code and Standards, ANSI A 1264.1, Revision 2007, Safety Requirements for Workplace Working Surfaces and Their Access, Workplace Floor and Wall Openings, Stair and Guardrail Systems, ANSI A 10.32, 2012, Personal Fall Protection Used in Construction and Demolition, and ANSI A 14.3, Revision 2008, Safety Requirements for Fixed Ladders. Fall Protection Requirements. General. The requirements of this section apply to all contractor workforces when their employees are working at heights, exposed to fall hazards, and or using fall protection equipment. Every contractor is responsible for establishing, implementing, and managing a fall protection program. The fall protection threshold height requirement is 6 feet or 1.8 meters for all work performed by contractor workforces, to include steel erection activities, systems engineered activities, i.e. prefabricated metal buildings, residential wood construction, and scaffolding work. Workers exposed to fall hazards shall be protected from falling to a lower level by the use of standard guardrails, work platforms, temporary floors, safety nets, engineered fall protection systems, personal fall arrest systems, or the equivalent. Fall protection is also required when there is a possibility of a fall from any height onto dangerous equipment, into a hazardous environment, or onto an impalement hazard. Fall protection is required when installing or removing sheet piles, H-piles, cofferdams, or other interlocking material, on access ways, climbing fixed ladders over 20 feet in height, and unprotected roof edges or floor openings. It is also required when conducting leading edge work, performing excavation work, working on formwork, or working off of work platforms. And also during rebar assembly, installing engineered metal buildings, during steel erection, or working over water, machinery, or other dangerous operations. The order of control measures or hierarchy of controls. The order of control measures, the hierarchy of controls to abate fall hazards or to select and use a fall protection method to protect workers performing work at heights. Elimination. Remove the hazard from work areas or change the task, process, controls, or other means to eliminate the need to work at heights with its subsequent exposure to fall hazards. This is the most effective control measure. Prevention. Passive or same level barrier. Isolate and separate fall hazards from work areas by erecting same level barriers. Work platforms, movable or stationary. Use scaffolds, scissor lifts, work stands, or aerial lift equipment. Personal protective systems and equipment. Use of fall protection systems, including, in order of preference, restraint, positioning, or personal fall arrest. Administrative controls. Introduce new work practices that reduce the risk of falling from heights or to warn a person to avoid approaching a fall hazard. Fall protection requirements when conducting inspection and investigation work. During construction activities, fall protection is required for all contractor employees exposed to fall hazards while conducting inspection, investigation, and assessment work. Prior to the start of construction or after construction work is complete, fall protection may not be required when conducting inspection, investigation, or assessment work more than 6 feet away from an unprotected edge of a roof. An AHA shall be developed and reviewed by a competent person for this activity and submitted for GDA review and acceptance. During maintenance evolutions, fall protection is required when conducting inspection and investigation work. This illustration describes the various control zones and safe zones for fall protection. As you can see, 6 feet in along the perimeter is the control zone, and fall protection is required when working or inspecting in that zone. In areas greater than 6 feet away from the edge is considered a safe zone. Fall protection may not be required in the safe zone when conducting roof inspection and investigation work. When accessing the roof from a ladder in that 6-foot area from the edge to the safe zone, guardrails or warning lines are set up to provide guidance for people transiting from the ladder. Roles and responsibilities. The personnel involved in the fall protection program include the fall protection program manager, qualified person for fall protection, competent person for fall protection, the end user, a competent rescuer, and an authorized rescuer. The fall protection program manager is responsible for the overall development, implementation, monitoring, and evaluation of the fall protection program. The qualified person for fall protection is responsible for technical support to the fall protection program. The competent person for fall protection is responsible for the immediate supervision, implementation, and monitoring of the fall protection program. The end user shall have an understanding of workplace activities and follow the policy and procedures and the instructions of the competent person regarding the use of fall protection and rescue systems and equipment. The competent rescuer is responsible for anticipating the potential for planned rescue and ensuring effective rescue plan and procedures and methods are in place before end users start their work at heights. The authorized rescuer is responsible to perform or assist in workplace rescues for personnel suspended in or attached to fall protection systems. Training. Training of all personnel involved in the fall protection program, including trainers, shall be in conformance with ANSI Z359.2 minimum requirements for a comprehensive managed fall protection program and ANSI Z490.1 standards, criteria for accepted practices in SH&E training. Refresher and update training shall also be in accordance with Z359.2 requirements. Fall protection program manager training shall be conducted by a competent person trainer or a qualified person trainer. Qualified person shall be trained by a qualified person trainer in proper inspection, assembly, and use of all fall protection equipment and systems that they will encounter in their work as a qualified person. Competent person shall be trained by a competent person trainer or a qualified person trainer. Note, acceptable competent person training is a minimum of 24 hours. This is applicable 18 months after the effective date of the EM 385 manual, and the training shall be a combination of formal classroom training and practical applications. End user training requirements. Each worker who might be exposed to fall hazards from heights shall be trained before using fall protection equipment by a competent person who is qualified in delivering fall protection training to the workers in the safe use of fall protection systems and equipment and the recognition of fall hazards related to their use, including the nature of fall hazards in the work area, the correct procedures for erecting, using, dismantling, inspecting, maintaining, and storing fall protection equipment, the application limits, free fall distances, total fall distance, and clearance, requirements of fall protection systems and equipment, rescue equipment and procedures, hands-on training and practical demonstrations, proper anchoring and tie-off techniques, and all applicable requirements from this section. End user refresher training. Refresher training shall be provided as necessary for the end user in the following situations: changes in the fall protection program that render previous training obsolete, changes in fall protection or rescue equipment render previous training obsolete, inadequacies in an employee's performance indicate a lack of knowledge or skill, or a condition in the workplace changes in a manner that could affect the safe use of the fall protection equipment. Refresher training is required for the following personnel to stay current with the fall protection educational requirements per ANSI Z 359.2 standard. Competent person every 2 years. End user every 2 years. Authorized rescuer every 2 years. And competent rescuer every year. Training and evaluations for fall protection and rescue training shall be documented and retained for the current and previous training program. Fall protection program. If a contractor will have personnel working at heights and or exposed to fall hazards, a fall protection and prevention plan shall be developed and submitted to the GDA for review and acceptance as part of their accident prevention plan. This plan may be developed by either a competent person or a qualified person. If the plan includes fall protection components or systems requiring direction, supervision, design calculations, or drawings by a qualified person, the name, qualifications, and responsibilities of the qualified person shall be addressed. It shall describe in detail the specific practices, equipment, and control methods used to protect workers from falling to lower levels. The plan shall be updated as conditions change and at least every 6 months. Site-specific fall protection and prevention plan. The plan is developed when personnel are working at heights, exposed to fall hazards, and using fall protection equipment, not otherwise protected by passive fall protection systems, for example, guardrails. It is developed specifically for the project, workplace, and task. It is site-specific. Site-specific fall protection and prevention program components. Contains the duties and responsibilities, description of the project or task, training requirements, anticipated hazards and fall hazard prevention and control, rescue plan and procedures, design and location of fall arrest anchorages and horizontal lifeline systems. The contractor shall identify all locations where anchorages need to be established and detail in the fall protection and prevention plan and the AHA. Inspection, maintenance, and storage of fall protection equipment, incident investigation procedures, evaluation of program effectiveness, and inspection and oversight methods employed. Fall protection systems. Guardrail systems. A guardrail system is installed at all open-sided floors, openings, and platforms where a person is required or permitted to work or pass. A standard guardrail consists of a top rail, 42 plus or minus 3 inches high, a mid-rail, erected halfway between the top rail and the floor, platform, runway, or ramp, and the posts shall be spaced no more than 8 feet apart. The ends of the top rails and mid-rails shall not overhang the terminal posts except where such overhang does not create a projection hazard. Strength requirements. The top rail shall withstand a force of 200 pounds applied within 2 inches from the top edge in any outward or downward direction. The mid-rail shall withstand a force of 150 pounds. Screens, mesh, intermediate vertical members, solid panels, and equivalent structural members shall withstand a force of 150 pounds. Top rails shall not deflect more than 3 inches when a 200-pound force described above is applied. Guardrail systems shall be so surfaced as to prevent injury to a worker from punctures or lacerations and to prevent snagging of clothing. Guardrail systems minimum construction material. For wood railings, top rails and posts, minimum size of 2x4. The mid-rail, minimum size of 1x6. And toe boards, minimum size is a 1x4. Note: wood railing components shall be a minimum 1,500 foot-pound per square inch fiber or stress-grade construction-grade lumber. Pipe railings should be a minimum 1.5 inch nominal diameter Schedule 40 pipe for the top rail, mid-rail, and posts. Structural steel railings, the top rail, mid-rail, and posts use a 2x2 by 3/8 inch angles. Extra guardrail is required for workers on stilts. When using stilts or working from raised platforms or floors above a walking working surface that exposes workers to a fall of 6 feet or more in areas protected by guardrails, the height of the guardrail must be raised accordingly to maintain a protective height of 42 inches above the stilt, raised platform, floors, or work stands. This slide shows two different types of guardrail systems typically used during roof work. One is a collapsible railing system to allow maintenance around the stack as shown in the left-hand picture, and on the right-hand side is a guardrail system which is removable and portable. Steel cable, when used as a guardrail system, the top rail and mid-rail is a minimum 1/4 inch steel cables flagged every 6 feet with highly visible material. Support posts shall be located to ensure proper tension is maintained. Steel cable may be used if tension is maintained to provide not more than 3 inches deflection in any direction from the center line under a 200-pound load. Perimeter safety cables shall meet the criteria and requirements for guardrail systems. If the perimeter safety cables are used by the workers as a methods of attaching a lanyard to the cables, they shall meet the requirements of a horizontal Lifeline system. Commercial, off-the-shelf engineered guardrail systems. This is an example of a strap rail. They shall be designed, engineered, installed, and used, and meet the requirements of Section 21. Guardrail systems, toe boards. The toe board shall be 3.5 inches in vertical height and shall be constructed from 1x4 lumber or equivalent. Toe boards shall be made of any substantial material, either solid or with openings between adjacent pieces not greater than 1 inch. Toe boards shall be able to withstand without failure a force of 50 pounds applied in any outward or downward direction at any point along the toe board. Where material is piled to such a height that a standard toe board does not provide protection, paneling or screening from the floor to the top rail or mid-rail shall be provided. Guardrail must be free of hazards of impalement, lacerations, punctures, or snagging of clothes. Guardrails receiving heavy stresses from workers trucking or handling materials shall be provided additional strength by using heavier stock, closer spacing of posts, bracing, or by other means. Guardrails around hoist areas. When guardrails are used at hoisting areas, a minimum 6 feet of guardrail shall be erected on each side of the access point through which materials are hoisted. A gate or removable guardrail section may be used as long as it meets the standard guardrail height of 42 plus or minus 3 inches and is secured across the opening between the guardrail sections when hoisting operations are not taking place. When removed to receive materials, employees must be protected by restraint or fall arrest systems. Existing parapet walls. Parapet walls are usually designed for 30 inches high, less than the OSHA guardrail height requirement of 42 inches plus or minus 3. Existing parapet height of 30 inches minimum is only permitted if the sum of the width and the height is more than 48 inches. Any combination of 30 inches or more in height plus width that equals 48 inches is acceptable. As shown in the diagram, X, the vertical height, and Y, the width of the pyramid, when added together, should equal to or be more than 48 inches. Floor holes, openings, and covers. Covers. Install covers on any hole 2 inches or more in its least dimension in walking working surfaces such as floors, roofs, or other openings. Covers shall be capable of supporting without failure at least twice the weight of the employee, equipment, and material combined. Covers shall be secured when installed, clearly marked with the word hole, cover, or danger, roof opening, do not remove, or color-coded or equivalent methods, for example, red or orange X, and workers must be made aware of the meaning of the color coding and the equivalent methods. The picture illustrates a compliant cover, which is a special device to cover plumbing holes. Hatches shall always be protected when opened. If a ladder is used to access through a hatch, it should extend 3 to 3.5 feet above the walking working surface. Safety nets. Safety nets shall be installed as close under the work surfaces as practical, but in no case more than 30 feet below such work surface. Nets shall be hung with sufficient clearance to prevent contact with the surfaces or structures below. Such clearance shall be determined by impact load testing. When nets are used on bridges, multi-story buildings, or structures, the potential fall area from the walking working surface to the net shall be unobstructed. Maximum size of the mesh openings shall not exceed 36 square inches, nor be longer than 6 inches on any side. The border rope or webbing shall have a minimum breaking strength of 5,000 pounds. Safety nets outward extension. Nets shall extend outward from the outermost projection of the work surfaces as shown below. 5 feet down from the work surface, they must extend at least 8 feet out. At 10 feet, the extension must be 10 feet or greater, and at 30 feet, 13 feet is the minimum extension distance. Testing of the safety net. Safety nets shall be tested in suspension and certified by a qualified person immediately after installation and at 6-month intervals with a 400-pound weight or sandbag not more than 30 inches in length, dropped from 42 inches above the highest walking working surface at which workers are exposed to fall hazards. Instead of the drop test above, it will be acceptable if the qualified person can demonstrate in writing that the testing of the safety net is unreasonable to perform and certified that it is in compliance with all the requirements and submit for review and acceptance by the GDA. Safety nets shall not be installed lower than 30 feet from the working surface. Inspection of safety nets. Per the manufacturer's instructions and recommendations, inspect the safety net immediately after installation, at least weekly thereafter, following any repair or alteration, and the inspection has to be documented. Immediately remove any debris that falls into the safety net. Shackles and hooks shall be made of forged steel. Defective nets shall not be used. This picture illustrates a safety net installation for residential or woods construction. Personal fall protection system, active fall protect. Personal fall protection systems, to include fall arrest, positioning, and restraint, shall be used when a person is working at heights and exposed to fall hazards. Personal fall protection equipment shall be used, inspected, maintained, and stored in a safe place in accordance with the manufacturer's instructions and recommendations or as prescribed by the competent person. Selection of personal fall protection equipment shall be based on the type of work being performed, the work environment, the weight, size, and shape of the worker, the type and position and location of the anchorage, and the required length of the lanyard. Inspection of personal fall protection equipment. Personal fall protection equipment shall be inspected by the end user prior to each use to determine that it is in a safe working condition. A competent person shall inspect the equipment at least once semi-annually and whenever equipment is subjected to a fall or impacted. Inspection by a competent person shall be documented. Defective or damaged equipment shall be immediately removed from service and replaced. Inspection criteria shall include harnesses, lanyards, straps, and ropes. Check all components for cuts, wear, tears, damaged threads, broken or torn stitching, discoloration, abrasions, burn or chemical damage, ultraviolet deterioration, and missing markings and/or labels. Hardware. Check all components for signs of wear, cracks, corrosion, and deformation. These pictures illustrate damage to personal fall arrest components. As you can see, there is damage to the webbing, and any damaged equipment shall be removed from service immediately. Personal fall arrest system. A personal fall arrest system, or PFAS, consists of a full body harness, connecting means, and an anchorage system. Note, all personal fall arrest systems shall meet the requirements contained in ANSI Z359 Fall Protection Code to include fall restraint and positioning systems. Personal fall arrest systems are generally certified for users within the capacity range of 130 to 310 pounds, including the weight of the worker, equipment, and tools. Workers shall not be permitted to exceed the 310-pound limit unless permitted in writing by the manufacturer. This picture illustrates the basic fall arrest system components. It consists of an anchorage, the steel beam, an anchorage connector, a beam clamp, a snap hook connecting the lanyard to the anchorage connector, a lanyard which connects from the anchorage connector to the dorsal D-ring on the harness, and a full body harness. Personal fall arrest system requirements. When stopping a fall, personal fall arrest systems shall limit maximum arresting force on the body to 1,800 pounds when used with a full body harness. The personal fall arrest system shall be rigged such that a worker can neither free fall more than 6 feet nor contact any lower level or other physical hazard in the path of the fall. The free fall distance of 6 feet can be exceeded if the proper energy absorbing lanyard is used. When designing new personal fall arrest systems, the qualified person shall attempt to minimize fall distances, including free fall distances and arrest forces. If it is necessary to increase free fall distances and arrest forces in order to accommodate existing and new structures or provide mobility to end users, only the qualified person can make this determination, and the maximum arresting force shall be kept below 1,800 pounds. Additional fall arrest system components, criteria, and use. Use only equipment meeting the ANSI Z359 Fall Protection Code and standards, including positioning and restraint equipment. All components of the system have to be compatible. All full body harnesses shall be equipped with suspension trauma preventers such as stirrups, relief steps, or similar in order to provide short-term relief from the effects of orthostatic intolerance. The full body harness. Personal fall arrest systems require the use of a full body harness. Only full body harnesses meeting the requirements of ANSI Z359 are acceptable. Full body harnesses labeled to meet the requirements of ANSI A10.14 shall not be used. Note, a frontal D-ring attachment point integrally attached to the wearer's full body harness and located at the sternum can be used for fall arrest, for example, used with ladder climbing devices, provided the free fall distance does not exceed 2 feet and the maximum arresting force does not exceed 900 pounds. Note, the use of body belts are prohibited. This slide illustrates the two different styles of body harnesses. One is the crossover style and the second is the vest style with a chest strap. The third illustration is a back view of the body harness showing the dorsal D-ring. Lineman's equipment or electrically rated harnesses. The full body harness used around high voltage equipment or structures shall be an industry designed lineman's fall protection harness that will resist arc flash and shall meet ASTM F887 and ANSI Z359, and the equipment must bear a label or similar stating such. Full body harness D-ring location on the harnesses. D-rings can be located in many positions on the harness. The dorsal D-ring is used in fall arrest, restraint, and rescue. The sternal D-ring is used in fall arrest, ladder climbing, work positioning, and rope access. The frontal D-ring is used for ladder climbing. The waist rear D-rings are used for fall restraint. Hip D-rings, located in pairs, are used for positioning. Shoulder D-rings, also located in pairs, are used for rescue, entry, and retrieval. Saddle D-rings are used in pairs and are part of positioning. Not all harnesses contain all of these D-rings. This slide shows the visual location of D-rings on the harness. As you can see, the sternal D-ring is typically located on the chest strap. The hip D-rings are on the sides. Saddle D-rings are located near the thighs. Shoulder D-rings are located on the straps at the shoulders. The dorsal D-ring is located in the middle of the back between the shoulder blades, and a waist D-ring is located around the belt at the rear of the person. In donning a full body harness, make sure that the harness fits snugly to the body. The wearer should be able to reach the dorsal D-ring with their thumb. A maximum of 4 flat fingers of slack can be inserted between the legs and the straps, and ensure the chest strap is located across the chest or breastbone. Inspection of a full body harness. They should be inspected for function. Do all connections work? Legs, chest, etc.? Can the harness be adjusted to fit? Does the harness have the correct connections for the job? Check for the condition. Where is the harness used, and what will I look for based upon what use? Has it been used for welding, and are there burn holes? Is the webbing intact? Inspect closely. Is there damage to the webbing? Are the impact indicators deployed? Is there any deformation to the D-rings or hardware? Is there damage, cuts, tears, soiled, burns, hardened paint, etc.? Connecting means. Connecting means is a method or subsystem used to connect the full body harness to the anchorage. The subsystem may include energy absorbing or shock absorbing lanyard made of strap, webbing, or rope with a snap hook or carabiner at each end, self-retracting devices, SRDs, and or a fall arrestor, a rope or a cable grab. Connecting means for lanyards with an energy absorber. This slide shows 3 different types of lanyards. All 3 contain an energy absorber. The one on the left has a self-retracting Lifeline device with it. The one in the middle, the energy absorber is internal to the lanyard, and the one on the right is your more typical 6-foot lanyard with an integral energy absorber. Energy absorbing lanyards. Energy absorbing lanyards, including ripstitch, tearing, and deforming lanyards, shall be capable of sustaining a minimum tensile load of 5,000 pounds. The maximum length of a single or Y lanyard used in fall arrest shall not exceed 6 feet. The 6-foot free fall energy absorbing lanyard shall only be used when the tie-off point is above the dorsal D-ring, creating a free fall distance of less than 6 feet. The energy absorber shall have an average arrest force of 900 pounds and a maximum deployment distance of 4 feet. See ANSI Z 359.13, paragraph 3.1.8.1. When an anchor point is below the dorsal D-ring, a free fall distance greater than 6 feet is created. For these situations, a 12-foot free fall energy absorbing lanyard shall be used in accordance with the manufacturer's instructions and recommendations. The energy absorber shall have an average arrest force of 1,350 pounds and a maximum deployment distance of 5 feet. The 6-foot and 12-foot free fall energy absorbing lanyards shall meet the requirements of ANSI Z 359.13. Y lanyards. When using lanyard with 2 integrally connected legs for 100% tie-off, attach only the snap hook at the center of the lanyard to the fall arrest attachment element of the harness, or D-ring. The 2 legs of the lanyard and the joint between the legs shall withstand a force of 5,000 pounds. Twin leg lanyard for 100% tie-off. When one leg of the lanyard is attached to the anchorage, the unused leg of the lanyard shall not be attached to any part of the harness except to attachment points specifically designated by the manufacturer for this purpose. The 6-foot free-fall Y lanyard shall only be used when the tie-off point is above the dorsal D-ring height and when the free-fall distance is less than 6 feet. When the tie-off point is located below the dorsal D-ring, the free-fall distance is greater than 6 feet, so a 12-foot free-fall Y lanyard may be used. The picture indicates a manufacturer's installed lanyard parking ring. The maximum arrest force on the body shall not exceed 1,800 pounds. The 6-foot and 12-foot free-fall energy-absorbing Y lanyards shall meet ANSI ASSE Z359.13 standards. Note, effective 2 years from the date of publication, all energy absorbers used shall be equipped with a deployment indicator. Do not tie the lanyard back to itself. A knot reduces the strength by 50 to 75%. This table presents a summary of the requirements for single and Y energy absorbing lanyards. As you can see, it discusses either a 6-foot free fall or a 12-foot free fall energy absorbing lanyards and lists the requirements for maximum free fall distance, average arrest force, maximum deployment distance, and lanyard and energy absorber strength. Inspection of energy absorbing lanyards. Energy absorbing lanyards should be inspected for the following. For function, is the proper energy absorber used according to end user weight and free fall distance? Do the snap hooks at the end of the energy absorbing lanyard work properly? Is the energy absorber compatibly connected to the harness and the anchorage? Condition, has the energy absorber been deployed? Is the energy absorber covering intact with no signs of damage? Is the energy absorber soiled or saturated enough to cause concern? Is the label legible? Are the stitch patterns and terminations intact? Is there any damage to the webbing? Energy absorbing lanyard labeling. This figure indicates the proper labeling for 6-foot free fall and 12-foot free fall energy absorbing lanyards. Hardware, also known as connecting components. Connectors, snap hooks, and carabiners. Snap hooks and carabiners shall be self-closing and self-locking, capable of being opened only by at least 2 consecutive deliberate actions. Snap hooks and carabiners having a minimum gate strength of 3,600 pounds in all directions per ANSI Z359.12 shall be used. Snap hooks and carabiners shall have a minimum tensile strength of 5,000 pounds. D-rings, O-rings, snap hooks, and carabiners shall be capable of withstanding a tensile load of 5,000 pounds. Connectors, adjusters, and any buckles used as adjusters shall be capable of withstanding a minimum tensile load of 3,372 pounds and shall be made of drop forged, pressed, or formed steel or made of equivalent materials, shall have a corrosion-resistant finish, and all surfaces and edges shall be smooth to prevent damage to interfacing parts of the system. All connecting components used in personal fall arrest systems shall be compatible and shall be used properly. Do not use non-locking snap hooks or carabiners. Connectors with the 3,600 pound gates can be identified by their markings. Using higher strength gates does not guarantee against failure. The connection has to be compatible. Carabiners. A carabiner is a connector with a trapezoidal or oval-shaped body and has a normally closed gate. Carabiners must have a minimum tensile strength of 5,000 pounds. Hardware compatibility. Using a locking snap hook or carabiner does not assure compatibility. Compatibility is achieved when dimension A is less than dimension B. The snap hook will self-correct in the event of a fall. Compatible versus non-compatible connections. Rollout occurs when the gate is pressured and forced open. Transverse loading is a concern with larger snap hooks anchored directly to the structure. Overhead and flexible connections assist in preventing gate loading. Use only self-locking snap hook with 3,600-pound gate. This picture illustrates the correct way for attaching a snap hook to the dorsal D-ring. This slide illustrates snap hook misuse. Do not attach two snap hooks to the same D-ring. Do not tie a snap hook to another snap hook. The bottom picture illustrates improper loading of the gate on a snap hook. Inspection of connectors. Connectors should be inspected for the following. For function, does the connector open and close as intended? Does the connector stick after being opened? Does the gate of the connector stay closed when pushing on it? Condition, does the connector appear to have any signs of rust, burrs, pits, deformation, or cracks? Self-retracting devices. Connecting means self-retracting devices classifications. Self-retracting devices, also known as SRDs. The SRDs shall meet the requirements of ANSI ASSE Z359.14 standard. A self-retracting lanyard, or SRL, is a device mounted or anchored such that the arrest distance shall not exceed 2 feet and the average arrest force shall not exceed 1,350 pounds or a maximum peak force of 1,800 pounds. SRL with leading edge capability, SRL-LE, is designed for applications where during use the device is not necessarily mounted or anchored overhead and may be at foot level, and where the possible free fall distance from the edge is up to 5 feet, and the average arrest distance shall not exceed 4.5 feet. The device is equipped with an energy absorber to withstand impact loading of the line with a sharp or abrasive edge during fall arrest and for controlling fall arrest forces on the worker. Additional requirements for self-retracting devices per ANSI Z359.14. Self-retracting lanyard, maximum arrest distance 2 feet. Average arrest force 1,350 pounds. Maximum peak arrest force 1,800 pounds. They are to be used only in vertical applications. An SRL with leading edge capability, or an SRL-LE. Maximum arrest distance of 4.5 feet. Maximum 5-foot free fall. Average arrest force 900 pounds. It is equipped with an energy absorber. Maximum peak arrest force 1,800 pounds. They can be used in horizontal or vertical applications. SRL with leading edge capability, SRL-LE. Maximum arrest distance 4.5 feet. 5-foot free fall distance. Average arrest force 900 pounds. They are equipped with an energy absorber. The maximum peak arrest force 1,800 pounds. They can be used in horizontal or vertical applications. Inspection of self-retracting devices. They should be inspected for function. Sharply pull the SRL line to test the locking function. Open and close the snap hook to make sure it doesn't stick and operates properly. Inspect the SRL impact indicator for signs of impact. Slowly pull the SRL in and out. It should pay out and retract smoothly. Condition. Inspect the SRL snap hook for corrosion, deformity, and damage. Look up the entire SRL distance. Inspect the exposed cable for kinks, bends, or broken strands. Inspect the SRL anchorage and connector for signs of damage. Do not open the SRL housing. The coil spring may cause injury. Any unit that requires repair should be sent back to an authorized service center. Swing fall hazards. Stay within a 30-degree cone to prevent a swing fall. SRL equipped with a deployment indicator. The red ring is a fall indicator. This SRL has been impacted by a fall and must be removed from service. Note, effective 2 years from the date of publication, all self-retracting devices used shall be equipped with a visual indicator. Connecting means, fall arrestor. A device that travels on a lifeline that will automatically engage and is designed to lock off by inertia to arrest a fall. Manual rope grab or rope adjusters are used only in positioning and restraint systems. Fall arresters or rope grabs are designed to be used with a vertical lifeline and ladder climbing devices, either rope, cable, or rail, and they shall be approved by the manufacturer for such use. Fall arresters shall have a minimum ultimate strength of 3,600 pounds. Note, for vertical lifelines or ladder climbing devices, use only the automatic fall arresters that move in one direction only. Automatic rope grab. Best for hands-free operation, used in vertical climbing and descending. Slides freely on the rope or the wire rope. Rope or cable grabs. The illustration on the left is a manual rope grab, and the illustration on the right is an automatic rope grab. Anchorage system. Personal fall arrest anchorage system. The anchorage system consists of the anchorage, the rigid part of the building, facility, structure, or equipment, and the anchorage connector. Anchorages used for attaching the personal fall arrest shall be independent of any anchorage used to support or suspend platforms. They shall be capable of supporting at least 5,000 pounds per worker attached or designed by a qualified person for twice the maximum arresting force to the body. Note, do not use electrical conduits, utility pipes, ductwork, or unstable points as anchorages for personal fall arrest systems. Anchorage connectors. Anchorage connectors are used to tie the personal fall arrest system to the anchorage and shall be capable of withstanding without breaking a 5,000-pound load per worker attached. Anchorage connectors shall meet the requirement of the anchorage to which it is attached to. Always consider the compatibility between anchorage and anchorage connector. These are examples of anchorage connectors. The picture on the left illustrates an adjustable energy-absorbing lanyard used as an anchorage connector. Lanyards should not be tied back to themselves unless they are designed to be tied back onto themselves. The picture on the right illustrates a tie-off adapter, also known as an anchorage strap. Other examples of anchorage connectors are permanent anchorage, a permanent anchor designed to be attached to wooden structures, a concrete anchor, or a tie-back anchor anchored into the brick of a building. Additional anchorages, roof anchors designed to be attached to either wooden roofs or steel-type roofs. The one on the right is a swivel roof anchor that incorporates a self-retracting lifeline. Other types of anchorages are roof anchors installed permanently to the building, a trolley running along an I-beam, or a plate anchor that can be attached to the vertical portion of a beam. An additional type is a removable eye-bolt, where a threaded section is built into the building and the eye-bolt can be threaded in as needed for anchorage use. Builder's grips, or other types designed to be inserted into concrete or through holes in other structural members. Continuing along, roof anchors designed to be nailed or attached to a roof, a wire hook type that can be used to attach to larger pipes, and permanent mounted D-rings that can be attached to building structural members. Non-penetrating anchors, which can be put on a roof and moved around as needed to provide fall protection for people working on a roof. Another type are specialty stanchions used for steel erection. These can be attached to the steel structure before it is being hoisted in place, and they provide fall protection for the steel workers as the building is erected. Additional examples of anchorage connectors: roof anchor posts adapt to all types of roof structures. They can be either mounted on a trolley system or designed to work on standing seam metal roofs. Portable anchorages are also available that can be either ballasted or weighted down with steel that allow temporary anchorages to be installed on roofs. Personnel working on concrete formwork, special anchorages are available that allow the workers on the face of the formwork to have an adequate anchorage. Other types, concrete anchor strap. In this type, the anchorage is actually placed over the rebar and then the concrete is poured over the anchorage. It provides an anchorage point for workers during construction, and it is cut off at the end of the job. And various types of D-ring anchors that can be anchored into the concrete after it has set. There are additional anchorage connectors. Some use a pole to facilitate attaching a connector to a high anchorage for the first person up. And there are adjustable freestanding horizontal rail systems that can be moved as needed to provide anchorage for people working at heights. Fall arrest considerations and total fall and free fall distance considerations. Prior to selecting a fall arrest system, the following information should be verified and considered: movement of the worker and type of work being performed, existing hazards or obstructions in the worker's path, location and availability of safe anchorages, total fall distance, free fall distance and available clearance, and swing fall hazards, compatibility of all components of the system, impact forces, and rescue or self-rescue considerations. The total fall distance considerations. Total fall distance is equal to the free fall distance and the deceleration distance. This figure shows the information needed in calculating fall distance. In this situation, using a 6-foot free fall energy absorbing lanyard attached to a point above the worker is standing on the working surface. There is a distance of 12 feet from the dorsal D-ring to the anchorage connector. It contains a free fall distance of 3 feet. Using the maximum 4-foot deceleration distance, it allows the total fall distance of 7.5 feet. The stretch of the harness adds an additional 6 to 12 inches in the suspension distance. The last point to consider is the height to the dorsal connector from the individual's feet. You also need to provide a 2 to 3 foot safety factor below the individual's feet to ensure that he does not strike any obstructions below him. And this is the calculation of the total fall distance. Using a 6-foot free fall energy absorbing single lanyard, the maximum fall distance could be 10 feet. Using a 6-foot free fall energy absorbing single lanyard with the anchorage overhead and the D-ring attachment approximately 2 feet below the anchorage point, the maximum free fall distance is 6 feet and the maximum deceleration distance of 4 feet. The maximum total fall distance of 10 feet occurs when the tie-off point is at the D-ring level. If the tie-off point is 2 feet above the D-ring, the total fall distance is 8 feet. Using a 12-foot free fall energy absorbing single lanyard, the maximum total fall distance of 17 feet occurs when the tie-off point is at the foot level. If the tie-off point is 3.5 feet above the working surface, the total fall distance is 3.5 feet. The maximum total fall distance of 10 feet occurs when the tie-off point or anchorage is at the D-ring level. If the tie-off point is 2 feet above the D-ring level, the total fall distance is 8 feet. Using a 6-foot free fall energy absorbing Y lanyard, the maximum total fall distance of 10 feet occurs when the tie-off point or anchorage is at the D-ring level. If the tie-off point is 2 feet above the D-ring level, the total fall distance is 8 feet. Using a 12-foot free fall energy absorbing lanyard, the maximum total fall distance of 17 feet occurs when the tie-off point is at the foot level. If the tie-off point is 3.5 feet above the working surface, the total fall distance is 13.5 feet. Lifelines. Vertical lifeline. A vertical lifeline is a vertically suspended flexible line made of rope with a connector at the upper end for tying off to 5,000-pound overhead anchorage, along which a fall arrestor, rope, or cable grab travels. In the event of a fall, the fall arrestor shall lock on the lifeline and remain locked until released. Vertical lifeline, also known as VLL. A vertical lifeline shall have a minimum tensile strength of 5,000 pounds attached to a single overhead anchorage. Each worker shall be attached to a separate lifeline system. Lifelines can be used in vertical, sloped, or horizontal applications, but it is not a horizontal lifeline. A fall arrestor equipped with an energy absorber is used in vertical lifelines. The energy absorber shall meet the ANSI Z359.13 standard. Additional information concerning vertical lifeline systems. Fall arrestors are designed to work with certain types and diameters of ropes or cables. Make sure the appropriate size and type of lifeline is used. The required size is marked on the rope grab. Use only automatic travel fall arrestors in vertical climbing or descending applications. Horizontal lifelines. Horizontal lifeline is a fall arrest system that uses flexible wire, rope, or synthetic cable spanned horizontally between two end anchorages and may include inline energy absorber or lifeline tensioner, turnbuckles, and intermediate anchorages. Locally manufactured horizontal lifelines are not acceptable unless they are custom designed for limited or site-specific applications by a registered professional engineer who is also qualified in designing horizontal lifeline systems. Commercially manufactured horizontal lifelines shall be designed, installed, certified, and used under the supervision of a qualified person only as part of a complete fall arrest system. The competent person, if deemed appropriate by the qualified person, shall supervise the assembly, disassembly, use, and inspection of the horizontal lifeline systems under the direction of the qualified person. The design of the horizontal lifelines shall include drawings, required clearance, instructions on proper installation and use procedures, proof testing reports, and inspection requirements. All horizontal lifeline anchorages shall be designed by a registered professional engineer who is also qualified in designing horizontal lifeline systems. The design of all horizontal lifeline systems shall be reviewed and accepted by the GDA as part of the Fall Protection and Prevention Plan. Depending on the angle of sag and the line's elasticity, the forces generated by a fall are greatly amplified at the anchorages. Here is an example of a horizontal lifeline. The two most critical components of a horizontal lifeline system are the anchorage strength and the angle of sag of the line. Horizontal lifeline components can include a shock absorber, a tensioner, and a mobile attachment device for moving between intermediate anchorages. The correct way to attach to a horizontal lifeline is by connecting the snap hook to the O-ring instead of attaching it directly to the line or cable to prevent non-compatibility. Here, a horizontal lifeline is being used as a restraint system. It has a traveler that overrides intermediate supports. If cables are used as guardrails and also used for tying off, they shall be designed as a horizontal lifeline. Positioning and restraint systems. Positioning system. A combination of fall protection equipment that permits the user to have both hands free while supported on an elevated vertical work surface, for example, a rebar assembly, towers, or poles. A positioning system uses some of the same equipment as a fall protection system, for example, harness, etc. However, a positioning system used alone does not constitute fall protection. A positioning system should not be used as a primary fall arrest system. While positioning, working with both hands free, a person shall use a separate system that provides backup protection from a fall. System requirements. A positioning system shall be rigged such that a worker cannot free fall more than 2 feet, be secured to an anchorage capable of supporting at least twice the potential impact load of a worker's fall, or 3,000 pounds, whichever is greater. Ensure workers achieve 100% tie-off during use. The attachment points on a full-body harness used in positioning system should be located on the sides or on the front of the harness. Here's an example of a worker on formwork using a positioning system, and you can see the backup system for fall arrest. A restraint system. Consideration shall be made for use of fall restraint over fall arrest. Fall restraint systems prevent the user from reaching an area where a free fall could occur by restricting the length of the lanyard or by other means. The anchorage strength requirement for restraint systems shall be 3,000 pounds or designed by a qualified person for 2 times the foreseeable force. Restraint systems can only be used on flat or low slope surfaces, less than 18.4 degrees or a 4 to 12 slope. Ladder climbing device. A ladder climbing device is a sleeve or cable rope attached to a fixed ladder over 20 feet in length. Anchorage strength for ladder climbing devices shall be a minimum of 3,000 pounds. The connector between the front D-ring of the harness and the ladder cable, rope, or sleeve shall be 9 inches long. The free fall distance when using a ladder climbing device shall not exceed 2 feet. There shall be a 100% transition at the top of the ladder climbing device for safe access above the work surface or the roof. Note: do not install ladder climbing devices on ladders that have 3/4 inch rungs, off-the-shelf ladders, unless the ladders are designed to withstand the fall forces. This is an example of a ladder climbing device that uses a cable and it's attached to a fixed ladder. It requires a 100% transition at the top. Inspection criteria for ladder climbing device systems. The ladder climbing device should be inspected for its function. Inspect the sleeves' moving parts, that they all move freely. Inspect the sleeves connector, that it is self-closing, self-locking, and operating properly. Place the sleeve on the system and lift it up and down. It should move freely. Lift the sleeve up and drop it. It should lock and engage. Condition: visually inspect the sleeve for any damaged or missing parts, corrosion, deformity, or rust. Inspect the snap hook carabiner for corrosion, deformity, or signs of damage. Stand at the bottom of the ladder and look up the length of the system. Inspect for any signs of damage, missing elements, or areas of the climb that may cause concern. During the climb, inspect the intermediate anchorages and top anchorages for secured bolts, corrosion, damaged parts, or improperly installed components. Scaffolds, work platforms, and aerial devices. Scaffolds shall be equipped with a standard guardrail per section 21F.01 or other fall protection systems. For workers erecting and dismantling scaffolds, an evaluation shall be conducted by a competent person to determine the feasibility and safety of providing fall protection if fall protection is not feasible. An AHA detailing rationale for infeasibility of the use of fall protection shall be submitted and accepted by the GDA. Self-supported and freestanding scaffolds. This slide illustrates the common types of scaffolds that may be encountered on a construction site. Fabricated or frame scaffold, a mobile scaffold, a pole scaffold, typically constructed out of wood, or a tube and coupler scaffold. Suspended scaffolds, single point or 2-point suspended scaffold. In addition to railings, the workers shall also be tied off to an independent vertical lifeline using a full body harness. Other suspended scaffolds, for example, catenary, float, needle beam, or bosun's chairs. Personal fall arrest system is required, and workers shall be tied off to an independent vertical lifeline using a full body harness. A risk assessment shall be performed when persons are supported on multi-point adjustable suspended scaffolds to evaluate the effectiveness and feasibility of the use of personal fall arrest systems. Results shall be documented in the AHA for the activity being performed. This slide shows several different types of suspended scaffolds. A catenary scaffold, a bosun's chair, needle beam scaffolds, or float scaffolds. A vertical lifeline is required for all suspended scaffolds. When working in single or two-point suspended scaffolds, in addition to railings, workers should also be tied off to an independent single anchor vertical lifeline using a full body harness. Self-propelled elevating work platforms covered by ANSI A92.6 or scissor lifts. Scissor lifts shall be equipped with standard guardrails. In addition to the guardrail provided, the scissors lift shall be equipped with anchorages meeting ANSI Z359 fall protection code. Note: scissor lifts not equipped with anchorages are prohibited. A restraint system shall be used in addition to guardrails. The lanyards, to include energy absorbers, used with the restraint system shall be sufficiently short to prohibit workers from climbing out of or being ejected from the platform. The use of a self-retracting device, SRD, is prohibited unless permitted by the SRD manufacturer and used in accordance with the manufacturer's instructions. Workers are prohibited from climbing on or over the guardrails. Aerial work platforms, boom-supported platforms covered by ANSI A92.5, and vehicle-mounted and elevating aerial devices covered by ANSI A92.2. This slide illustrates boom-supported elevating work platforms and vehicle-mounted elevating work platforms. Workers shall be anchored to the basket or bucket in accordance with the manufacturer's specifications and instructions. Anchoring to the boom may only be used when allowed by the manufacturer and permitted by the competent person. Lanyards used shall be sufficiently short to prohibit the worker from climbing out of the basket. Lanyards with built-in shock absorbers are acceptable. Self-retracting devices are not acceptable. Tying off to an adjacent pole or structure is not permitted unless a safe device for 100% tie-off is used for transfer. Occupants shall stand firm on the floor of the basket or bucket and shall not sit or climb on the edge or use planks, ladders, or other devices. Tying off using personal fall arrest systems is required. Manually propelled elevating work platforms per ANSI A92.3. These are examples of typically manually propelled elevating work platforms. This slide shows other examples of manually propelled elevating work platforms. If the platform is equipped with anchorages meeting ANSI Z359, a restraint system shall be used in addition to the guardrails. Lanyards used with the restraint system shall be sufficiently short to prohibit workers from climbing out of or being ejected from the platform. Lanyards with built-in shock absorbers are acceptable. Self-retracting devices are not acceptable. The platform shall not be occupied when moved, and at no time will workers be allowed to climb on or over the guardrails. Warning line system and designated area. Warning line system is a barrier erected on a roof to warn workers they are approaching an unprotected side or edge. A warning line system may only be used on floors or flat or low slope roofs between 0 and 18.4 degrees or less than a 4 to 12 slope during construction work and shall be erected around all sides of the work area. A warning line system shall consist of wires, rope, or chains 34 to 39 inches high with supporting stanchions. The warning line system shall be flagged at not more than 6-foot intervals with a high visibility material. The wire, rope, or chains shall have a minimum tensile strength of 500 pounds and after being attached to the stanchions shall be capable of supporting without breaking the loads applied to the stanchions. Stanchions shall be capable of resisting without tipping a force of 16 pounds applied horizontally against the stanchions 30 inches above the walking working surface, perpendicular to the warning line and in the direction of the roof, floor, or platform edge. The line shall be attached at each stanchion in such a way that the pulling on one section of the line will not result in a slack being taken up in adjacent sections before the stanchion tips over. Roofing work. On flat roofs, the warning line system shall be erected not less than 6 feet from the edge. When roofing work is conducted on low-slope roofs, less than a 4-12 slope, or when using mechanical equipment, or when work is performed by other trades, for example, mechanical contractor performing work on equipment located on roofs, the warning line system shall be erected not less than 15 feet from the unprotected side or edge. This slide illustrates a warning line system in use. It indicates the height between 34 and 39 inches high. It shows the base of the stanchion and how the line is connected at the stanchion to prevent it from sliding between the different stanchions. Designated area used for general industry work. A designated area is used as a fall protection method during maintenance work, for example, inspecting or maintaining HVAC equipment on roofs. The requirements for the designated area are identical to the warning line system. In addition, a 100% transition is required from the access point on the roof to the designated area. This slide shows a designated area used for general industry work. It's used on roofs during maintenance work, for example, inspecting or maintaining HVAC equipment, not roofing work. It is similar to a warning line system for construction. As you can see, there is a 100% transition area from the ladder to the designated area. Prohibited fall protection systems. Safety monitoring system, controlled access zone, and a fall protection plan. Safety monitoring system. A competent person designated to oversee workers when it is not feasible to provide other fall protection systems. Workers will be exposed to fall hazards. The use of a safety monitoring system as a fall protection method is prohibited. A controlled access zone. The use of a controlled access zone as a fall protection method is prohibited. A controlled access zone is similar to a warning line system. It is established when fall protection cannot be provided to personnel exposed to fall hazards. It's allowed only per OSHA Subpart M. Rescue plans and procedures. The employer is required to provide prompt rescue to all fallen workers. A rescue plan shall be prepared and maintained when workers are using fall protection equipment. See ANSI Z 359.2, Written Rescue Procedures. The plan shall contain provisions for self-rescue and assisted rescue of any worker who falls, including rescue equipment. If other methods of rescue are planned, for example, a jurisdictional public or government emergency rescue agencies, it shall be indicated in the rescue plan, including how to contact and summon the agency to the mishap site. Personnel conducting rescue shall be trained accordingly. If required, anchorages for self-rescue and assisted rescue shall be identified, selected, and documented in the site-specific fall protection and prevention plan. Anchorages selected for rescue shall be capable of withstanding static loads of 3,000 pounds or 5 times the applied loads as designed by a qualified person. Workers using fall protection equipment shall have an assigned safety person or spotter, also known as the buddy system, who will be within visual or verbal range to initiate rescue of the fallen worker if required. Here's an example of self-rescue and assisted rescue equipment. An evacuation harness, an anchorage connector for rescue with synthetic rope tackle block, an evacuation harness, anchorage strength required is 3,000 pounds, and on the right illustrates a synthetic rope tackle block. Other self-rescue and assisted rescue equipment could be a self-retracting lanyards with rescue capability, either motorized or manually controlled, self-retracting lanyard with winches for rescue, or a personnel hoist. Additional equipment needed for rescue could be a rescue davit system, a rescue Y lanyard, or a rescue lanyard. Rescue equipment continued. A full body harness shall be equipped with suspension trauma preventers such as stirrups, relief steps, or similar in order to provide short-term relief from the effects of orthostatic intolerance. As shown, the strap is used to prevent suspension trauma. The use of 2 straps is required, 1 for each leg. Working over water. Working over water or near water. For example, piers, wharves, quay walls, barges, aerial lifts, crane-supported work platforms, etc. Personal flotation devices are required for all work over or near water unless detailed below. Note 1. All contractor workers, to include divers, shall comply with the requirements below. Note 2. If utilizing personal flotation devices with a full body harness, the full body harness shall be worn under the PFD. The type of PFD used shall not interfere with the proper use of a full body harness and lanyard. When continuous fall protection is used, without exception, to prevent workers from falling into the water, the employer has effectively removed the drowning hazard and personal flotation devices are not required. Note that when using safety nets as fall protection, U.S. Coast Guard approved personal flotation devices are usually required unless rationale is provided in the AHA. When working over or near water and the distance from the walking working surface to the water's surface is 25 feet or more, workers shall be protected from falling by the use of a fall protection system, and personal flotation devices are not required. When working over or near water where the distance from the walking working surface to the water's surface is less than 25 feet and the water depth is less than 10 feet, fall protection shall be required and personal flotation devices are not required. When working over water, personal flotation devices, life-saving equipment, and safety skiffs meeting the requirements of this EM shall be used as required. When working from, in machinery, mechanically operated equipment, aerial lift equipment, or other movable work platforms, cranes, directly over water and the depth of the water is at least 10 feet deep, fall protection is not required. However, personal flotation devices are required. When there are hazards from currents, intakes, dangerous machinery or equipment, or barges, etc., fall protection shall be required regardless of the fall distance, and personal flotation devices are not required. This flowchart can be used to determine whether fall protection or personal flotation devices are required to be used when working over or near water. Other engineered fall protection systems. Commercially available engineered or integrated systems are recognized as effective fall protection and may be used. These are systems that are not addressed in Section 21. Commercially available engineered integrated systems shall be designed, installed, certified, and used only under the supervision of qualified personnel and used per the manufacturer instructions and recommendations. The competent person may, if deemed appropriate by the qualified person, supervise the assembly, disassembly, use, and inspection of the engineered system under the direction of a qualified person. The design shall include drawings, required clearance, instructions on proper installation, use, and inspection requirements. These systems shall be reviewed and accepted by the GDA as part of the Fall Protection and Prevention Plan. This picture illustrates other fall protection systems. This one is known as Skyweb and provides fall protection for people from falling to a lower level.